Guys, Mr. Bowman here. Today's learning objective is in pink, and we are learning to use sample space to solve probability problems. And that idea of sample space is the key thing we're going to focus on today. I've also got a Pokemon here. I've tried to do a really hard one. So if you know the name of this guy, please put it in the comments below. So we're going to get back to sample space. And sample space relates to the possible number of combinations or outcomes. So the possible number of combinations or outcomes. And why the sample space and having a really good understanding of it is important is because of the approach we're taking with our probability question. So we're using a probability of whatever the event is, don't forget about your notation, is equal to F over T. So to understand that T, you need to be aware of all of the combinations or outcomes that exist. And that, if we circle back, is the combinations or outcomes or the sample space that we referred to above. We've got two questions in green that we're going to go through just to highlight this idea of sample space and how you can use various tools to help you get there. So the first question I've got, if I throw 3 coins, what's the probability of getting 2 heads and 1 tail? So for this type of question, there's no real tool you need to do. You need to think, well, what's the probability of 2 heads, 1 tail? We need to think about F over T. And to go through F over T, we need a list. We need, well, what are all the combinations that could happen? So let's just jump in there. If you got a head first, head second, head third, and then let's say that last one changes. So we've got head, head, tails. We've then got head, tails, heads, heads, tails, tails. So we can see we've got all combinations starting with head. We can then flip over to tails. Well, we could have tails, tails, tails. We could have tails, tails, heads. That last one changing, tails. Maybe the middle one has changed now. And then maybe both have changed now as well. So if you throw 3 coins, there are 8 unique outcomes. And that relates to the total outcomes. So our denominator or our total will be 8. And then you've got to think of these 8 combinations or of your sample space, how many of them would be 2 heads and 1 tail? You have a look. So here's 2 heads and 1 tail. Here's another. And there's another down the bottom there. So 3 of our sample space would be that. So that's 3 over 8. If you convert to a decimal, which you should more often than not, 0.375. So that was an example of sample space. We've found out all our total outcomes, 8 of them. And then we found out, well, of our sample space, how many of them are favorable in terms of the question, 2 heads and 1 tail. Okay, so we got our next question down there in green. We're going to move away from lists for this. We're going to try to use a bit of a table to help out as well. So if I roll 2 dice, what is the probability of getting 10 or more? And this is where I suggest we use a bit of a table. And let's say all the outcomes over here of dice 1, we're going to list 1, 2, 3, 4, 5, and 6. And on the top there, all of the outcomes for dice 2, 1, 2, 3, 4, 5, and 6. So while we're using dice, this could change. This could be like the marbles in a bag or the letters in a word, whatever it might be. But these dice 1, dice 2 can change. And then you can consider all the combinations. So in this square here, that relates to getting a 1 on the first dice and getting a 1 on the second dice. And then we're going to repeat that across. So 1 and 2, 1 and 3. And then we complete our whole table. So that there would be 1, and then you got, oh sorry, bad maths there. That there would be 2, we had 3, 4, 5, 6, and 7. And you'll notice a pattern happening. So this one here would be the 1 and the 2. So that there's going to be 3. And then you got 2 and 2, 4, and it goes up by 1 every time. 5, 6, 7, 8. You're then going to have the same pattern going down. 4, 5, 6, 7. With that pattern, you don't even need to look at the dice combinations. You can just get into it. So that there would be 5, 6, 7, 8, 6, 7, 8, 9, 7, 8, 9, 10, 8, 9, 10, 11, 9, 10, 11, and 12. You can also see some other patterns happening. You can see the numbers popping up diagonally as well. So that there represents our sample space of rolling 2 dice. We can see there is 6 combinations in every row, which gives us a total or 36 unique combinations this dice could have landed on. So when you're thinking of your notation, probability of x being greater than or equal to 10, x being that dice roll that we don't know about, that probability is equal to f over t. The total number of rolls is 36. How many of them are favorable in the terms of 10 or more? And we can see these lots here. Don't forget it's in 10 or more as well, so we include 10. If it's in more than 10, we would ignore the 10s. But this time around, our sample space shows we've got 6 unique combinations. So we've got 36 over 6. That there is 1 over 6. And as you switch that to a decimal, 1667. And that had a 4dp rounding. So guys, hopefully you can see about how thinking about the sample space or all the total possible unique combinations or outcomes of an event come into play. Thank you so much for watching, guys. Now let's get into heaps of practice.